Here's question 2 from our practice test number 1 for equilibrium and rates of reaction. And this question is about a chemistry exam. So below is an excerpt from a chemistry exam showing the question and the student's response. We should have an apostrophe there. Anyway, question 4 says, write an equation for the system. So here is our system at equilibrium. You can see its concentration is changing as we go along and we reach equilibrium. So therefore, they think the equation is this. So discuss the errors in the student's response to question 4a and 4b and provide the correct solutions below. So let's first of all break this question up into 4a. So 4a, what is wrong here? So what has the student done? Write a chemical equation for the system. So we've got A forming B. What we've got here? So A is this thing we're starting with, and B is increasing over time. So we do have A as our reactant and B as our product. So that's one good thing. A is a reactant and B is a product. So that's one thing the student is done. Student is correct in that statement. This is an equilibrium system. Students only put a forwards arrow. So the system is equilibrium, and which means that arrow should be used. So this type of arrow is only if you know that the reaction is going to completion, so something for like a combustion reaction or not a closed system. Here you can see that the system is coming to equilibrium, and therefore your equilibrium arrow should be used in writing an equation for it. Lastly, we have our coefficients, and here we've got 1a forming 2b. Let's just double check that on this here. So what we want to look for is what the change in the reactants and products will be. So this is going from 100. So 100 down to 40 equals a change in 60% in concentration. So this here, that's gone down to 40, so that's a 60% change. That means that if it was A forming 2B, B should go up to 120 because the ratio here suggests that we form twice as much B as we do A. But in our question here, you can see that it's only going up to 60. So therefore, it's not. The ratio should be 1 to 1. And that's where they've stuffed that up as well. So therefore, what we should say is the correct answer should be A with an equilibrium arrow, with a gaseous system by the looks of it, to B. There's no reference to it being gaseous, but we'll just assume that's right. But that's where this equation here comes into it. It should be A equilibrium to B, where you've got the equilibrium arrow because it's not going to completion, and the ratio is based upon the change that occurs within our graph here. Now, 4b, let's discuss that. What have we got here? Indicate on the graph to the left when equilibrium is reached. What did the student say? The student said that equilibrium was reached here. Now that is not true because what we've got is the concentrations are still changing at that point. We've got the concentrations of A and B being equal, but that's not what equilibrium is. Equilibrium is when the concentrations don't change anymore. So therefore the student is wrong. The student has said equilibrium is when the concentration of A equals concentration of B, which is not correct. Not correct. Okay, what actually happens is equilibrium is when the concentrations are consistent. Equilibrium, I'll try and write this in here, I haven't got much room with this one, but equilibrium is when concentrations are constant. So therefore, how should I write the solutions? So on here, I'm going to say equilibrium is actually at this point here. Equilibrium is here, all right? When the concentrations of reactants remain consistent. I think it'll probably be about here. you can see they're constantly going up, but it's around about flat around about here. So equilibrium is here when concentrations of things are constant. And that's how I would kind of go about responding to this. Looking at what the question's asking, I'll go through and think about what would the right response be and how do I actually obtain this and what is the difference between a correct response and what these responses are here. Question B is rewrite the student's response to part C to include reference to collision theory. So what was collision theory? What is happening to the rate of the Ford's reaction as the system reaches equilibrium? So what happens to the Ford's reaction? It decreases as the amount of reactants decreases. Now that's true, but it has no reference to collision theory. So I would say the reactants decrease. Therefore, the concentration of reactants decrease, which leads to a lower frequency of successful collisions. And that's where we got to go collision theory. How do I link this to collision theory? The reactants decrease, so therefore the concentrations of the reactions, so therefore it leads to a lower frequency of successful collisions. Now I should say between reactant particles, because I'm only talking about my Ford's reaction. Sorry, up here. I'm only talking about my Ford's reaction, so therefore my collisions for my Ford's reaction are the collisions between the reactant particles. So if I need to reference collision theory, I need to go to my buzzword, which is the frequency of successful collisions. And I need to say, what are those collisions between? These ones are my reactant particles. And that's the answers to question 2.